All right, ladies and gentlemen, it is time to review the pKa of carboxylic acids. For example, butanoic acid, 4-carbon carboxylic acid, has a pKa of what? Uh-oh. It's taking a little too long, everybody. 5. Yeah, that's a normal carboxylic acid, right? 5. That's the only number I want you to learn, okay? Don't say, oh, he's going to make us learn more numbers. No. You know me in trends, right? Are you going up or down? That's the only important thing. And all of these are carboxylic acids except for one. Can you find the one that's not a carboxylic acid? Hot. Good job. She saw the big full name of hot. Or TSOH, I'm giving all the short forms. Or the one that has a little more information, PTSOH. They're all the same, okay? But that's not getting you points for drawing the acid. You get 0. You're renaming the acid. So do you remember what a sulfonic acid looks like? What element must it have in it? Clearly, sulfur. How many bonds to oxygen does this sulfur have? Careful. It's based on sulfate, which has 6, but it's attached to an organic chemical, so one of the O's is gone and replaced by a carbon. So 5. And how many pi bonds to O? Sulfur. We better learn sulfur, guys. 2. Yeah, its most oxidized state, it can have up to 6 bonds to O. Here's the acid part. So any sulfonic acid looks like this. Any sulfonic acid looks like this. And you got to draw me a paratoluene group now, right? So what do you draw first? And it's very appropriate. In our future, we're going to learn about benzene. So we're going to draw a benzene, which is really, when benzene's a group, it has another name, right? Starts with a P. What is that group called? Phenyl. And a toluene is a phenyl that has a methyl on it. The only question now is, where does the methyl go? You got 3 separate spots. Ortho. There's 2 ortho positions. This is a preview. Ortho means one away from a substituent. Meta, M-E-T-A, not Facebook, no. Meta means 2 away from a group. There's 2 meta positions. Do you see them? And we're not looking for either one of those. We're looking for the P. What's that stand for? Well, it's right there. Para. You put the methyl on the para position to finish this question. So there's para. And why methyl? Because this is called toluene. By itself, it's a common solvent. Nice solvent. It's less dangerous than benzene, less carcinogenic. So we don't use benzene much anymore. We used to use it all the time. Chemists back in the 40s and 50s were using benzene like ladies are using acetone on your nail polish remover. Benzene does a nice job too, but it's not good for you. They didn't know. Okay. And please don't use toluene. You won't like the result. The odor is just like, oh, you won't like that. So. Yeah. Now, guys, we're also supposed to know the pKa of that one, and it's not anywhere near 5. Yeah, -5. That's a whole different category of acid, isn't it? So those are the only 2 pKa's you're basing this whole question on. So I already know he's top dog, right? We're naming them. How do you think you're going to do alpha chlorobut? I didn't write the word acid. That was just my mistake. Can you make sure acid's at the end here? How do you draw that one? You copy the one above it. Yeah, where's alpha again? Right next to the carbonyl. And go down to the next one. Where's beta? Next to. Just curious, what's next? If I had another Greek letter, what's the next one? Gamma. And I couldn't go to delta on this molecule, could I? You're out of carbon. Okay, benzoic. I repeat, if you see benz in a name followed by anything, you draw a phenyl and a carbon. If you see benz, B-E-N-Z, in a name, and it's followed by something other than E-N-E, if it's benzene, you just draw this, right? This ring, without the orange. When it's benz anything else, you draw the phenyl. Doesn't have to be in the, well, red's fine. You draw another carbon. You get a snip. There, benz. There's your minimum. Now you've got to make that carbon sticking off into what functional group? Carboxylic acid. Well, the red part is the benz, and then we made it a carboxylic acid. So far, so good. And what about 2-butene-oic acid? Well, you got your but and oic acid. You got carbon number 2, and it's got a double bond, right? I suppose I drew E2-butenoic acid. I could have drawn Z as well because I wasn't asked which one. I wasn't asked to be specific, I'm sorry. And this is a new group here. That's new. You've never seen that in nomenclature. We're learning it now because it's important. It's in a lot of pharmaceutical agents like drugs. It's popular. Anybody know any pharmaceutical agents that have a nitro in them? Nitroglycerin, yeah. It'll have this in it. That's nitro. Learn it forever. Why is it so important? Well, in terms of biochemistry, so that medicine she was talking about, nitro group, is a vasodilator. It causes blood vessels that are constricted, which causes things like high blood pressure, to dilate. Your pressure goes down immediately, right? Because your volume went up. So here we're going to attach it to benzoic acid. Now tell me where carbon 1 of benzoic acid is. There's benzoic acid. Carbon 1 is here. 2 is there, 3 there, 4. Okay. And you just say 2 is one, it's right here. 1 is where it's an acid. 2 is 1 away. And the most important thing you need to know about nitro is the most electronegative substituent. Oh, I like that word, substituent. Like a group inorganic chem. Greater than fluoro. What? You thought fluorine was the most electronegative element on the periodic table? You were right. That did not change just now. This is not an element, is it? But in terms of like withdrawing electrons, pulling electrons, it does that more efficiently than, or more strongly than fluorine. Okay? So remember that. It's got a couple things going on. It's got that charge and resonance. But we have a question.
Use, the ortho?
You could have used ortho. Good question. Or O nitro benzoic acid. And O stands for O equals ortho. She remembered what we talked about when we were constructing our para-toluene sulfonic acid. And I'm glad she did. And that's a little preview. We'll be seeing ortho, meta, and para again when we study aromatics as a chapter, but that's test 3. We're working on test 2, right? Okay, so where are we at? We've got all the names and pictures drawn. I think it's a good video stop, and we'll pick up with part B in the next video. Put them in order of increasing acidity and explain. So don't hand it in. We will be right back.